Hello, today we are looking at the dot product of vectors and the power that the dot product can give us. So the dot product is very simple. It is not scalar multiplication. It is a very specific type of multiplication, and it is as such. So suppose I've got two vectors. I've got vector A and I've got vector B. What the dot product is, and it is written this way right on over here, A dot B, it's telling me that the dot product is equal to the magnitude of A multiplied by the magnitude of B multiplied by the cosine of the angle theta that is between the two angles. And we're going to see how this can help us figure out what the angle is between two vectors. It's really very powerful. But let's just test out how this works. So suppose that I've got vector A, I should say that's the magnitude of A, is equal to 13. The magnitude of vector B is equal to 5. And I know that the angle between the two is 31 degrees. So I can set up my dot product, A times B, A dot B, excuse me, I should not say times, I should say dot, because there's another type of multiplication we'll look at later. A dot B is equal to the magnitude of A times the magnitude of B times the cosine of the angle between them. Substitute in 13 times 5 times the cosine of 31. And I can put that into my calculator. And I get 55.7. So A dot B is going to equal 55.7. Notice this is not a vector. You have a quantity here, which is a scalar. Not the same really as just good old scalar multiplication. This is the dot product, but this does not result in a vector. So that is method 1. Method 2. If I know the component vectors of A and B, so I can multiply the vertical, or excuse me, the horizontal of A times the horizontal of B plus the vertical component of A times the vertical component of B. If I multiply them by each other, I will get the exact same dot product. So let's look at another example. I've got vector A, and you can see right here that it's got a horizontal component of 5, a vertical component of 12, and vector B has a horizontal component of 4 and a vertical component of 3. So to get the dot product, I would do A dot B is equal to AX BX plus AY BY. And my horizontal for A is 5. Horizontal for B is 4, plus the vertical for A times the vertical for B, plug all that into your calculator, and that gives me 56. That is the dot product. If we have some rounding, we might not have something that is exactly the same. Notice I'm really using the same A and B here for both of these, which leads us to the power of the dot product. If I set these equal to each other, I can determine this very easily if I know the component vectors of the vector. And if I know the component vectors, then I can easily find the magnitude. What this allows me to do is figure out what the cosine is. So I can figure out, once I know the cosine, I can figure out what the angle is between the two. Remember we said A looked something like this, B was this. This angle that is in between, I normally don't know, given anything we've studied to date, very easily. But as long as I've got this other information for A and for B, now I can solve that. So let's put it into play. So again, I'm going to use the same information I had from before. My magnitude of A is 13, and we said the magnitude of B was 5. Let's say we don't know what this is. Let's say we don't know the angle between the two. And I've got over here my, we said that the horizontal for A was 5 and B was 12. And the vertical for, excuse me, not 12, 4. My apologies. The vertical for A was 12 and the horizontal was 3. Excuse me, the vertical for A was 12 and the vertical for B was 3. There we go. We've got a lot of numbers we're working with right now. That's why we write everything down so that we don't get confused. But say I don't know what this cosine is, then I can rewrite this as 13 times 5 times the cosine of theta is equal to 5 times 4 plus 12 times 3. So 13 times 5 gives us 65 cosine of theta is equal to, we can simplify all of this on the right. In fact, we did just a moment ago, and we said this was 56. To get cosine of theta by itself, divide both sides by 56. Excuse me, 65, not 56. That would be not so helpful. Divide both sides by 65. And we get the cosine of theta. I try and leave as much of this in my calculator as possible so that we don't get too much divergence from an accurate answer by rounding. I'm going to go just for the heck of it to the 10,000ths here. Usually I just use the second answer key in my calculator just to store that. Now I need to do the inverse cosine of both sides in order to get out the cosine. And that will leave me with theta is equal to 30.51 degrees. Whoop. And this is not that far off from what we saw when we originally plugged in back here. Theta equals 31. If we round this 30.51 to the nearest degree, that would be 31 degrees. So that's the power of the dot product. It's fairly easy to compute, and then you are able to use that to find the angle between vectors. Okay. Look over this, think of any questions that you may have, and we will talk more about this tomorrow. I hope you have a great day.